Welcome to another deep dive. Today, we're going to be looking at Terraform, some key concepts.
Right.
And we're pulling these from, the Terraform interview questions 2630.pdf
Right.
that you sent over. So whether you're prepping for a job interview or
Yeah.
just looking to really up your Terraform game, we are not just skimming the surface today.
Let's do it.
We're going to dive deep.
Sounds like a plan. Let's get into it.
Okay, so this first code snippet really grabbed my attention. It's creating a security group, but it's doing it dynamically. So what's the advantage there?
Right. So it's using a dynamic block
Yeah.
within the security group resource.
Mm-hmm.
And the magic's in that for each loop. It generates ingress rules based on variables. So you're not stuck writing each rule by hand.
So variables are like a shortcut then, especially for complex setups. I get that part. But then there's this thing, Terraform refresh. I've always been a bit fuzzy on that command. Isn't applying changes, kind of like the whole point of Terraform.
It's a little subtler than that. So Terraform refresh syncs your state file with your actual infrastructure. It's not about making changes. It's about making sure Terraform's understanding of what's out there is up to date.
Oh, so what happens if they don't match up? Like, say somebody manually tweaks a server setting outside of Terraform.
That's exactly what we call drift.
Yeah.
And that's where things get dangerous. If Terraform's state is out of sync, your next apply could have unintended consequences. It might try to revert those manual changes, or worse, create conflicts. Terraform refresh helps you catch that before it becomes a problem.
Okay, that makes that refresh part a little clearer, like a safety check before you do any heavy lifting. Now, no tool is perfect, right?
Of course,
Terraform's got to have some downsides, too.
every tool has its limits. One thing to be super careful about is the state file itself. Mishandling that, especially with multiple people working on the same project, is a recipe for disaster, corruption, conflicts, you name it.
So if I'm in a team, how do we avoid stepping on each other's toes? Is it like a Google Doc where somebody's edits overwrite everyone else's?
We use a mechanism called state file locking. Make sure only one person can modify the state file at a time. This snippet here actually shows how to set that up using DynamoDB with an S3 backend.
Hold on, DynamoDB. That sounds heavy duty. For just keeping a file safe, can you break in how that lock actually works?
Think of it like a virtual checkout system.
Yeah.
When someone wants to make changes, they acquire the lock, kind of like borrowing a library book. While they have the lock, nobody else can make changes. Once they're done, they release the lock, and someone else can grab it. DynamoDB acts as the central authority, managing these locks, ensuring everything stays synchronized.
Got it. So no more accidental overwrites now, I've noticed that. Even in simple projects, Terraform code can get pretty dense. Any tricks to keep things readable, especially as things scale up?
One technique is using local values. They let you create temporary variables within your code, making things cleaner and more maintainable. See here, local.instDiscount and local.amid are used to avoid repeating those values throughout the code.
That does make it more concise. But wouldn't overusing local values make the code harder to follow in the long run? You'd have to keep track of all those extra variables.
That's a good point. It's a balancing act. Local values shine when they improve clarity. Without introducing too much complexity, the key is to use them strategically, not just for every single value. Think of them as simplifying complex expressions, rather than replacing every variable declaration.
Okay, so it's about finding that sweet spot between conciseness and clarity. Makes sense. Now, what about situations where I only want to create resources under certain conditions, say deploying different things based on the environment?
You can do that using count or for each. This instance example uses count to create an instance only if the create instance variable is set to true.
So I could have one configuration file, but deploy different sets of resources just by toggling some variables. That's powerful stuff. But before I go wild with that, is there a safe way to test these expressions before they go live?
I think every Terraform user has that fear. That's where Terraform console comes in. It's essentially a sandbox where you can test expressions, play with variables, and see how things evaluate without making any actual changes to your infrastructure.
So it's like a test kitchen for my Terraform code. I can experiment and debug
Exactly.
before serving it up to the production environment.
It's an invaluable tool for building confidence and avoiding those oh no moments when you accidentally deploy something you didn't intend.
I like the sound of that. Speaking of risks, let's say I have a resource that's technically working, but I know it needs to be replaced. It's like an old car still running, but
I get the analogy.
one breakdown away from the junkyard.
We're talking about situations where you want to force a refresh, even if Terraform doesn't detect.
So it's like a force refresh button for individual resources. When would I actually need to use this?
It's useful when you're dealing with underlying issues that Terraform can't detect, like configuration drift or outdated dependencies. Sometimes you just need a clean slate.
Okay, I'm starting to see the value in that. Now, we keep mentioning this all-important state file. It obviously holds a lot of sensitive information. Where does this file actually live?
That's where backends come into play. They define where your state file is stored, either locally on your machine or remotely. Using a remote backend like S3 is generally the best practice, especially for collaboration and security.
So it's like a centralized hub for our infrastructure information. Rather than having it scattered on individual computers, what are the benefits of storing it remotely, besides just security?
With a remote backend, your team can access the same state file, ensuring everyone's working with the latest information. It also enables features like locking, preventing conflicts, and accidental overwrites. Plus, cloud platforms like S3 offer built-in redundancy and backups, so you don't have to worry about losing your state file if your computer crashes.
That makes a lot of sense. A shared repository for infrastructure with backups. Sign me up.
Okay, last scenario for you. I inherit some infrastructure that wasn't built with Terraform. Can I bring it under Terraform's control
Absolutely.
without starting from scratch?
Terraform has you covered there too. With the Terraform import command, you can import existing resources into your state file.
So it's like adopting those pre-existing resources
Exactly.
into the Terraform family.
But there is a catch. While Terraform import updates the state file, it doesn't actually create the corresponding resource configuration. You'll need to write the resource blocks manually to reflect those imported resources in your code.
So it's not a complete magic wand. Still, that's better than having to redeem everything from the ground up. Exactly.
It's a powerful tool for bringing legacy infrastructure under Terraform's management, saving you time and effort. I'm really seeing the depth of Terraform now. We've covered a lot from dynamic resource creation to managing the state file like a pro. But I'm curious, what are your favorite Terraform features or techniques?
That's a great question. What really makes you go, aha, when you're using it? For me, it's the power of modules. They allow you to encapsulate sets of resources and configurations,
Modules like pre-built templates for common setups.
sort of like building blocks for your infrastructure.
That sounds incredibly useful.
They promote reusability, consistency, and make your code much more manageable. It's like having a library of pre-built infrastructure components
Yeah.
that you can plug and play into different projects. And you can even create your own modules to encapsulate your specific infrastructure patterns.
So instead of copying and pasting the same code over and over again,
Precisely.
I can create a module for a web server cluster, for example, and then just reuse that module.
It saves you time,
Whenever I need to deploy a new cluster,
reduces errors, and makes your code much easier to maintain. And the best part is, you can use modules created by others, tapping into a vast community of shared knowledge and best practices.
wow, that opens up a whole new world of possibilities. It's like having a team of Terraform experts at my fingertips. But modules aside, what other features make you excited about using Terraform?
The flexible configuration options offered by variables and outputs always impress me. Variables allow you to pass in values to your Terraform code at runtime, so you can customize your deployments without modifying the code itself.
So I could have a single Terraform configuration for different environments like development staging and production,
Exactly.
and just change the values of certain variables to deploy to each one.
It streamlines your workflow and makes your code more adaptable. And outputs let you expose values from your Terraform code.
Expose values, what does that mean and why is it useful?
Outputs essentially let you extract information from your Terraform code and use it elsewhere, for example. You could output the IP address of a newly created server and use that value in a separate script or configuration file.
So outputs act as a bridge, allowing different parts of my infrastructure to communicate with each other. That's really cool. And I imagine it's especially handy
Absolutely.
when you're dealing with the complex interconnected systems.
And Terraform provides a variety of built-in functions and expressions that let you manipulate and transform these variables and outputs, giving you a lot of flexibility in how you design your infrastructure.
This is all starting to sound incredibly powerful. We've come a long way from just basic resource creation.
That's the beauty of Terraform.
We're talking about managing complex interconnected systems
And as you delve deeper,
with flexibility and control.
you discover its true potential, automating and streamlining your infrastructure management in ways you never thought possible.
This is definitely inspiring me to explore further. It's like we've opened a treasure chest of tools and techniques, but I think it's time for a quick pause to let all this sink in.
A break would be great. We've covered a lot of ground.
We'll be right back after a short break to delve even deeper into the fascinating world of Terraform. Don't go anywhere. And we're back, ready to continue our Terraform deep dive. Before the break, we were just geeking out about modules, variables, and outputs. I'm really starting to see how all these pieces fit together to build some seriously sophisticated infrastructure.
It's like moving from crafting individual tools to designing an entire workshop. Each element has its purpose, but their real power comes from how they work together.
You mentioned that modules can come from a community library. That sounds amazing, but also a bit intimidating. How do I know if a community module is reliable? What if it introduces security risks or conflicts with my existing setup?
That's a valid concern. It's crucial to vet community modules carefully. Look for well-maintained modules with clear documentation, recent updates, and plenty of positive feedback. Check the source code, understand the dependencies, and test them thoroughly in a sandbox environment before integrating them into your production code.
So due diligence is key, just like with any third-party software. But let's shift gears back to those variables and outputs. You said variables can make our configurations more adaptable, but I'm still wrapping my head around the practical applications. Could you give me a real-world example?
Sure, imagine you have a Terraform configuration. For deploying a web server, you could use variables to define things like the server size, operating system, and application version. Then you could create separate variable files for different environments: development, staging, production, each with different values for those variables.
So instead of maintaining 3 separate configurations, I could have one base configuration and just switch out the variables. Depending on where I'm deploying, that's way more efficient. But what about outputs? How do they fit into this picture?
Imagine your web server module outputs the server's public IP address, another module, responsible for setting up a load balancer. Could then use that output as an input, automatically connecting the load balancer to the newly created web server.
Outputs allow different parts of our infrastructure to talk to each other, almost like an internal messaging system. That's super cool. It feels like we're building a self-aware infrastructure.
And that's not too far off. The goal is to create infrastructure that can adapt and react to changes. And outputs play a crucial role in enabling that communication and dynamic behavior.
Okay, so we've got modules for reusability, variables for adaptability, and outputs for interconnectivity. What other pieces of this Terraform puzzle are we missing?
One crucial aspect we haven't discussed yet is the concept of providers. Remember, Terraform isn't limited to just one cloud platform or service. Providers act as the bridge between Terraform and those various platforms.
We touched on this briefly earlier when talking about state file backends on S3. So if I wanted to manage resources on, say, Azure, I'd need the Azure provider, right?
Exactly. Each provider is a plugin specifically designed to interact with a particular platform or service. You declare which providers you need at the beginning of your configuration.
So it's like teaching Terraform a new language so it can speak to different platforms.
That's a great analogy.
Yes.
And the beauty of it is you can use multiple providers in the same configuration.
So I could potentially manage resources on AWS, Azure, and Google Cloud,
Exactly.
all from a single Terraform configuration.
Terraform gives you the flexibility to manage your entire infrastructure,
That opens up some interesting possibilities for multi-cloud deployments.
regardless of where it lives.
This is starting to feel less like a deep dive and more like an epic saga. We've gone from individual resources to modules, variables, outputs, and now multi-cloud deployments. What other grand adventures await us in the world of Terraform?
There's always more to explore. One area worth mentioning is the vast ecosystem of tools and integrations surrounding Terraform.
Tools and integrations. That sounds intriguing. What kind of tools are we talking about?
There are tools for visualizing your infrastructure, validating your code, managing your state files, and even integrating Terraform into your CI/CD pipelines.
So we're talking about an entire ecosystem built around Terraform, not just the core tool itself. It's like a bustling city with all sorts of specialized services,
Exactly.
catering to the infrastructure management world.
And as Terraform continues to evolve, this ecosystem will only continue to grow, offering even more powerful tools and capabilities.
I'm starting to feel like we've only scratched the surface. What are some specific tools you'd recommend exploring further?
One tool I find particularly useful is Terraform Graph, which visually represents your infrastructure as a graph. It can be helpful for understanding complex dependencies and identifying potential issues before you apply your changes.
So instead of just reading lines of code, I can actually see a visual representation of my infrastructure.
Absolutely.
That's fantastic, especially for those of us who are more visual learners?
And there are other tools, like tflint and checkoff, that help you validate your Terraform code for potential errors, security vulnerabilities,
Yeah.
and best practice violations.
These tools sound like lifesavers, especially as our infrastructure grows more complex. It's like having a team of experts constantly reviewing our work,
Exactly.
catching potential issues before they become problems.
They provide an extra layer of confidence and help you build robust and reliable infrastructure.
Wow, we've covered so much ground in this deep dive. We've explored the core concepts, delved into advanced techniques, and even ventured into the wider Terraform ecosystem. But as much as I'd love to keep exploring, I think it's time for another quick pause.
I agree. A break would be good. We covered a lot of information.
We'll be right back to wrap up our Terraform adventure. Stay tuned. We are back for the final stretch of our Terraform deep dive. I'm feeling a bit like I just completed a crash course in infrastructure orchestration. We talked about so many powerful features, from dynamic resource creation to multi-cloud deployments. What else should we consider as we start putting all these skills into practice?
One thing that often gets overlooked is documentation. It might not be the most glamorous aspect, but clear, concise documentation is essential for maintaining your Terraform code, especially as your infrastructure grows.
You mean documenting things like variable definitions, module usage,
Exactly.
and even the overall infrastructure architecture?
Think of it as creating a user manual for your infrastructure, future you, and anyone else who needs to work with your code will thank you for it.
That makes a lot of sense. It's easy to get caught up in the excitement of writing the code and forget about the importance of making it understandable for others and even for ourselves down the road. What other tips would you give to someone just starting out with Terraform?
Start small and iterate. Don't try to build your entire infrastructure in one go. Begin with a simple project, experiment with different features, and gradually build up your complexity.
So it's like learning any new skill. Master the basics before tackling the advanced stuff. Are there any specific resources or learning paths you'd recommend for those eager to dive deeper?
The official Terraform documentation is a great starting point. It's comprehensive, well-written, and packed with examples. There are also fantastic community resources, like HashiCorp Learn, which offers free interactive tutorials.
Now, what about those community modules we talked about earlier? Where can people find those?
The Terraform registry is the go-to place for finding and sharing modules. You can search for modules by keyword, filter by provider, and even see ratings and reviews from other users.
It sounds like a treasure trove of pre-built infrastructure components ready to be deployed. But with so many options, how do you recommend navigating the Terraform landscape and staying up to date with the latest trends and best practices?
Following industry blogs, attending conferences, and engaging with the vibrant Terraform community are all great ways to stay current. The Terraform community is incredibly active and supportive, always eager to share knowledge and help each other out.
It sounds like a perfect environment for learning and growing. It's amazing to see how Terraform has evolved from a niche tool to a cornerstone of modern infrastructure management.
It truly has become an indispensable tool for anyone working with cloud infrastructure, offering a level of automation, flexibility, and collaboration that was unimaginable just a few years ago.
Well, this has been an incredible journey through the world of Terraform. We've covered so much ground,
It's been a pleasure
from the fundamentals to the nuances,
sharing these insights and exploring the possibilities with you.
the challenges to the triumphs. And to all of you listening out there, we hope this deep dive has sparked your curiosity and equipped you with the knowledge to confidently embark on your own Terraform adventures.
Remember, the best way to learn is by doing. Start experimenting. Explore the documentation. Engage with the community. And don't be afraid to make mistakes. That's how we all grow.
That's our deep dive into the world of Terraform. We've barely scratched the surface of what you can do, but hopefully this has given you a taste of the power and flexibility at your fingertips. What are you most excited to try out first? Share your thoughts. We love hearing from fellow Terraform explorers. Until next time, keep building amazing things.